Okay, kindly subscribe my channel and keep watching my videos. Today we are moving towards section 3, where topic waves, with its section 2, which is related to light over there. And in the light, we will study about reflection of light, and the second section will be a refraction of light over there will be studied in this topic. And according to section 3, I will also going to be focused about um, refraction of waves according to their refractive index. A refractive index. I will also talk about total internal reflection, internal reflection. I will also talk about critical angle. Angle will be there. And we will also discuss about Snell's law in refraction of light. We will talk about the main use of Snell's law using to find the critical angle and their optical fibers behavior over there. Optical fibers will also be go under discussion over there. If I talk about light, basically light is a transverse wave which travels at the speed of 3 multiplied 10 raised to power 8 meter per second, and light travels the straight path. And if some opaque object is coming in this pathway, it makes a shadow over there. So if I talk about more in detail of this light energy, basically light is a form of waves which we take to be in the form of electromagnetic waves also, because they can come through the space, electromagnetic waves, and they don't require any medium for their propagation over there. And let's talk about the first phenomenon of reflection of light over there. For that purpose, as we say in case of simple reflection of waves, then waves are striking over the medium, then they are reflecting back into the same medium over there if the surface is smooth or maybe rough over there. But if they are not able to enter into the second medium over there, then reflection of light is going to happen. So reflection of light. Reflection of light. When light falls on a smooth medium, like having a smooth surface of ocean in the time of dawn or dusk, I'm saying light is striking, light is striking, light is striking. Then it is reflecting back, reflecting back, reflecting back. Then there is a proper pattern, that there is a regular point of view of these waves to reflect back into the same medium over there. Such type of reflection is called regular reflection over there. But if I talk that the surface is not smooth, surface is like a sandy desert like that, then light is striking in a parallel way, but the reflection is not in a proper direction. They are showing their direction to be not so much parallel over there. So that is called irregular or diffused reflection. Irregular or diffused reflection over there. If I talk more in detail, then I will say here that we can say that regular and irregular reflections, both after discussing them according to their surfaces when they are smooth and when they are rough, we will have to move towards the laws of reflection properly. Laws of reflection. If I talk about them, Then I will say, for example, let's suppose there is a surface or just like a mirror surface over there on which a light ray is going to strike over at this point, and it is reflecting back into same medium, and I am taking here a normal line to be drawn over here as a perpendicular over this surface. Then this is the angle of incidence and this is angle of reflection, over there. And this is incident ray. And this is called a reflected ray. According to laws of reflection, I will say here incident ray, reflected ray, and normal lie on the same plane over there. This is called that all three are lying in the same plane. And the second law of reflection states that angle of incidence is always equal to angle of reflection over there. So whenever visible light is a transverse wave, like electromagnetic wave, so reflection of visible light is what allows us to see most of objects, and light bounces off into our eyes, and the object which I am watching must be kept in the light over there, or light should fall over it. And when the light reflects from an even surface, smooth or skinny like a mirror, as I have given you the example over there, then all it's reflected in the same angle, and we get a clear reflection over there. So I have little bit labeled and explained about this. Remember that incident ray is a ray of light and normal is an imaginary line. Normal is imaginary line, perpendicular on the surface medium. Perpendicular on the surface of medium over there, on the smooth surface of medium over there. Over there. So the angle of incidence is the angle always being taken between the normal. Here you can see here that if I am changing the color over there so that I can highlight it, I'm saying here that this is the angle between this normal line and this angle of incident ray over there. This angle is called angle of incidence. Never try to take with this surface with the surface of medium, no. And angle of reflection will also not be taken with the surface. It will be taken with the normal line over there. Remember these 2 points while labeling or asking in the questions over there. You will have to take care about it. And if I go towards the mirror section of the reflected light over there, then how the mirror is going to happen over there, mirror. I'm talking about plane mirror here. Plane mirror is basically if showing the same behavior over there, then I am saying I have to go for a little bit elonging over there. Just look at here what I am doing. I am saying that the light is going to strike on this point and it is reflecting the same behavior I am taking. I am saying this is the mirror, which is shown by the green color over here. This is the mirror. And then I am saying what is happening basically that there is an object which is lying. For example, I am saying this is the object which is lying in front of this mirror. What is happening that the eye is present over here. Eye is present over here, which is going to watch that object over there. This is the eye. What is happening? I am looking into the mirror. And now I am saying here, while looking into the mirror, what is will happen over there, that this object is going to fall two rays over the surface of mirror, and they are reflecting back into my eye. And the other ray I am also taking here is coming back towards my eye over there, and I am getting its image. But the image which I will observe will be behind the mirror here, and I am also increasing this line to be exactly at that point, which is equidistant from the object and the image also over here. So object is in green color and image is in black color, just to highlight you. Otherwise, when you are using this plane mirror to observe this object and image over there, I will say here that the image of this object will be laterally inverted. Only left and right will show in opposite direction over there. On the other hand, they have the same size of both image and object over there. They will be at same distance, just to be in imaginary form and distance. And at the number 4, I will say that it will give me a virtual image, which I will not be able to get on any screen or any digital form over there to be stored in this form. So here, the two rays which I highlighted over here, and those are called incident rays. And these two are reflected rays over there. So I think the concept behind the plane mirror is now explained to you, and try to be connected with the next part of this class over there. Let's move now towards refraction of light now, and refraction of light. I will state here that refraction of light is going to happen when waves travel at different speeds in the substances which have different densities. Like electromagnetic waves travel more slowly in denser media usually. Sound travels faster in denser media like that. And so when waves crosses a boundary between two substances, the glass or air, it changes speed. For example, I am saying to you here, like I am taking a rectangular glass slab over there. What is basically happening, I am saying that the light is coming and going to fall on this surface by this ray. It is going to refract from its original path and then again coming out in a parallel way. So it is going to refract towards its normal over there. Like it is angle of incidence. It is called angle of refraction over there. And when light enters from a rarer medium to denser medium, then ray is refracted towards normal. On the other hand, if I change, I say some light is present inside the denser medium and it is coming out from rare towards the rarer medium, then it will move away from its original path over there, and refraction, and it can be taken in the form of lenses towards being taken in the form of refraction of light over there. If the wave hits the boundary face on, then it slowly down but carries in the same direction. For example, I am saying the ray is falling perpendicularly. It will pass straight line and it will not change its direction at all when it is facing on. But if wave meets the medium at a different angle, then the part of wave hits the denser medium layer first and slows down, like it is slowing down and it is showing towards the refraction little bit near its normal surface over there. So if I say here that a ray diagram I have already drawn for you, and refracted ray and normal and incident ray is shown over there. Incident ray is meeting at the point of normal over there, and at the boundary, and angle between the ray and the normal. Always remember, ray and the normal should be the angle. Ray and the normal. Always. Not take here. Never. This is angle of incidence, and the angle with the normal and refracted ray is called angle of refraction over there. And for if I go towards more in detail towards this refraction of light, then I say there are basically two laws. The first law is the same, that incident ray, a refracted ray, and normal lie on the same plane. And on the other end, we can say if we take a constant ratio between sine is a trigonometric ratio, sine of angle of incidence to sine of angle of refraction when light is entering from rarer medium to denser medium, low density medium to high density medium over there, then I am saying sine I over sine r is equal to a constant called a refractive index over there. And this is also called Snell's law. And always remember that when I take this refraction through a triangular prism, that this refraction is going to happen by a triangular prism, then I will say here that this refraction is going to be taken into account by in the form of, for example, this is a triangular prism over there. What is happening that the light ray, white light is entering into the side of a prism, triangular prism over there. Then different wavelengths of light are refracted by different amounts. So white light disperses into different colors like that. It is going to be shown like this, and it should go like in a straight way, but it shows to show a little bit a refraction, and the light is going to be shown in the form of a division over there, where red light is above and violet light is below, with the 7 colors which we know about. Wib Goyer, which means it is violet, it is indigo, it is blue, it is green, it is orange, it is yellow, and at the end is red. If I talk about here, red is showing the minimum refraction, while violet is showing the maximum way refraction from its original path over there. So similar effect happens when light leaves the prism, which means you get a nice rainbow effect as it happens in the natural rainbow over there. So rainbow effect can be observed over there, that we are seeing the refraction of light, white light in the 7 colors over there. So when I move towards the refractive index, which I said about in Snell's law over there about refractive index, then I will say here, it can also be stated some other formulas depending upon the data and different types of numericals over there, that your refractive index can be stated as refractive index can be taken as speed of light in vacuum, like speed of light in vacuum, that can be taken as C over speed of light in medium. Like you are talking in water, like you are talking in a transparent plastic, I'm taking the speed like V. Then refractive index, I know it is denoted by N. Then the formula will be N equal to speed of light in air over V. Speed of light in air, in the start of the lecture, I told you 3 multiplied 10 raised to power 8 should be divided by speed of light in the medium over there. And if we go to say that light slows down a lot in glass, so refractive index of glass is high. And the refractive index of water is bit lower, so light does not slow down as much in water as in glass over there. So remember that when the refractive index is high, the speed will decrease much. So refractive index of plastic is, if we compare that the refractive index of water is bit lower, then the speed will be larger over there. So slowing down phenomenon can be explained on the basis of refractive index of the material over there. Sometimes, for example, I simply tell to you that there is a glass of water, and what you are doing basically, you are doing to take some glass of water over there, and you are filling it, and then you are dipping a pencil into it. Then what is happening? Even though when you are observing from outside, then you feel that the base of the pencil is little bit uplifted. Now the actual depth is from here to here, but apparent depth is shown by here to here. This is when I take this difference of depths of liquid over there, then refractive index can be stated as actual depth ACTUAL, actual depth of liquid to apparent depth. That will also give me the refractive index value on the depending upon of data. So I use 3 different representation for refractive index. So whenever you are provided by the different scenarios of your numerical sections, then use in an appropriate way over there. After that, refractive index and critical angle over there. Now I am talking about refraction and reflection in the both ways over there. What is basically happening over here? For example, you are standing and you are observing the beach from here. As a person, you are standing over here and the sun is rising. The sun is rising over at this point, and it is early morning. What is happening? The sun is throwing its light here, and you are observing at in this form. So it means light is not entering into water, but when the sun is here, what is happening basically? You are not able to see those rays coming from the sun after striking with the ocean over there. What is the difference behind it? The difference is basically this is the normal line. When you are taking your this normal line, you are taking your angle of incidence like in this form. What is happening? It is entering in this water over there to show some refraction over there, or maybe bending towards normal over there. And when you are increasing it, then it means there is a point when you strike it and it becomes exactly parallel and making a 90-degree angle of refraction with the normal over there, then we can say it is called critical angle. Critical angle, in which I can say such angle of incidence whose angle of refraction is 90 degree. It's called critical. But when you increase more your angle, like in the early morning, what is happening like this, if angle of incidence is greater than critical angle, then light does not enter into second transparent medium, does not enter into second transparent medium, but it reflects back into same medium. It reflects back into same medium. This is called total internal reflection. And this total internal reflection is also helpful in optical fibers to transfer the electrical signal or light signal in the form of data to be transferred with the help of this total internal reflection over there. So I had tried to explain here to you towards total internal reflection. If I go towards critical angle, then I will say here, for example, I am going towards critical angle and Snell's law to relate that. Then I will say sine of critical angle will equal to 1 over n. So n is equal to sine 90 degree over sine of C over there. So this can be taken in case of critical angle for calculating the phenomenon of refractive index over there. And optical fibers are made up of plastic or glass, consist of central core and cladding and jacket over there. For example, I am taking here this and this layer. Then I am taking here, I'm saying this is the main layer. After that, I am taking the second layer here. In the last, I am taking this last one also. I am showing by different colors over there. This internal one is called core. And this big one is called cladding. And the above one is called jacket. Core and cladding are having the difference of their refractive index, core and cladding. And which is helpful for n is the refractive index of core, refractive index of cladding over there. Then the core of fiber is so narrow that light signal passing through it always hit the core cladding boundary at angles higher than critical angle. So total internal reflection is happening, and it only stops working if the fiber is bent too sharply. Then it stops bending is going to play its role over there. This total internal reflection allows to use the prism to see that are not our direct line of sight. This is how like this total internal reflection is being used in the form of periscope, like endoscope, gastroscope, medical purposes. Doctors mostly use that. The ray of light travels into prism where totally internally reflected by 90 degree. It then travels to another prism lower down and is totally internally reflected by the another 90 degree. And the ray is narrow traveling towards it should be taken into account. This was related to your light topic over there. I talked about periscope. I talked about, I can say, the lenses and other phenomenons of microscopes over there can also be taken into account over there. In the last, if we move towards the last section of waves over there, that is related to sound waves over there. That will be the last section. And we will watch that section in the next video. Sound will be done in the next lecture, inshallah. And here I will state you that lenses portion, which is the most important portion in O levels and IGCSE, is not included in IGCSE International GCSE Edexcel Physics over there, not included. So not to worry. In the classes of O level, I will inshallah add lenses also. And in the next video, we will move towards sound waves and their effect on their frequencies and their pitch over there. Thank you so much for today, and Allah Hafiz.